Good morning, students. In last class already we are completed about oscillating magnetic needle time period. So that is we are identified as T is equal to 2 pi root over I divided by MB. So here I is we are taken as moment of inertia of the given magnetic needle, M is we are taken as magnetic moment, and B is we are taken as magnetic field or magnetic induction. Like that we are represented. See, for that concept we are ready to discussing one small application here. What is the application means? Two magnets of magnetic moments M1 and M2. If suppose here M1 is greater than M2 we are mentioned, are placed one over the other if T1 is the time period when like poles touches. So when like poles touches each other, time period is T1 is given, T2 is the time period when unlike poles touches each other. So in this condition, what is the ratios here we will represent means T2 square by T1 square is equal to, we will represent M1 plus M2 by M1 minus M2. So reason is we people know T is inversely proportional to 1 by root capital M. So this is a way of representing T2 square by T1 square is equal to M1 plus M2 divided by M1 minus M2. This is one fundamental formula. So in another way this is also represents as M1 by M2 is equal to T2 square plus T1 square by T2 square minus T1 square. Like this also we will represent. This is just we are using formula for solving problems in objective conditions. Then we will go for Gauss law in magnetism. Before starting a Gauss law, students, I want to discuss about magnetic flux. Means how we can discuss about magnetic flux. The total number of magnetic field lines coming out normally through a unit north pole of a given magnet only we are calling as a magnetic flux. So in case of magnetism, Gauss law we are discussed means the net magnetic flux through any closed surface around a number of magnets is always zero. Here magnetic flux in any closed surface we are getting as zero only. Here why the reason means the total number of magnetic field lines are always balanced. A number of lines entering and number of lines leaving from the magnet is becomes balanced. So what the thing will happen, the net flux is becomes zero. Is it clear, students? For example, this is one closed surface we are taken. Here we are projecting some magnetic field like that. Here that closed surface area vector will be acts in this direction, so that area vector and that magnetic field will be makes an angle theta with each other. Then here flux is we are represented as flux phi is equal to, we can represent as b bar dot ds bar. How we will represent b bar dot ds bar? Ds bar is nothing but here we are taken as area vector. So now students, therefore d phi value is equal to b bar dot ds bar we are taken. Then by dot product d phi value is equal to b ds cos theta. Since people know a bar dot b bar is equal to ab cos theta. So the total flux through closed surface is we are taken as sigma b bar dot ds bar is equal to 0 from statement. This is the one simple thing we are representing. So then one more thing, students, now I am ready to solving few problems based on the concept of vibration magnetometer or time periods of magnetic needle. See students, this is very simple question for you. The time period of magnet at a place of magnetic field 4b is t. See here given b1 is equal to, I am taken as 4b is given. Here how much is given, what's the relation we are representing? A time period how much is given, t1 is equal to t is given. The time period at a place where the magnetic field is b. Now new magnetic induction, that's value is b. Now time period t2 is equal to how much expecting. We know the formula, that is time period t is equal to 2 pi into root over I divided by mp. One formula we have. So therefore t is inversely proportional to root to b. Therefore can we represent like this, t1 by t2 is equal to root over b2 by b1. Therefore t1 value is already t is given, t2 we want to calculate into root over this one b2 value is b, this one is becomes 4b, so bb cancel, therefore here we are getting as t by t2 value is equal to 1 by 2, therefore t2 or new time period is 2t, so value is becomes how much, 2t value is equal to 2t we are identified. Okay students, this is the result for us. Then one more problem now I am starting. See students, this is a simple question. A combination of two magnets performs 10 oscillations per minute when similar poles together and 6 oscillations per minute with dissimilar poles together. Means here for like poles together, now frequency, that's value let n1 is equal to here 10 oscillations per minute is given, and for unlike poles together, that is n2 value or frequency value 6 oscillations per minute is given. Just I am taking this is the first frequency and this one is the second frequency. Okay, the ratio of the magnetic moments is now expecting m1 divided by m2 value is equal to how much. Here we have one formula, m1 divided by n2 value is equal to here as n1 square plus n2 square divided by here n1 square minus n2 square. Since reason is n1 is greater than n2, so in denominator I am taking here n1 square minus n2 square students. So by substituting this, m1 by m2 is equal to, this is 10 square plus 6 square divided by here 10 square minus 6 square. So this value becomes 100 plus 36 divided by 100 minus 36. So this value is 136 divided by 64. Finally, we will get m1 divided by m2 is equal to, by calculations here 17 by 8 we will find. How much times? m1 by m2 is equal to 17 by 8, or we are taking this one as m1 is to m2 is equal to 17 is to 8. This is the answer for this simple question. Okay students, so one more problem, once observe carefully students. Here the period of oscillation of a suspended thin cylindrical magnet is 4 seconds. Means here t is equal to 4 seconds is given. Okay, it is broken into exactly two halves. Find the period of oscillation of each of when freely suspended. So let this is a t1, we want to calculate a t2. Initially I will take I1 is equal to I. Okay, for here thin cylindrical metal means, okay, for thin rod or thin magnet, what is the moment of inertia? I value is equal to ml square by 12. This is the one fundamental value. This is ml square divided by 12 is the thing. So this is the rod. This rod is we are divided into two pieces. Two pieces means, for example, along the length I am divided into two pieces like this. This is a thin rod. Then now I am taking I2 value is equal to, mass becomes a half for each piece. This is total mass m. So this is mass becomes a half here. So mass is becomes a half here. Length also becomes a half. So length is taking L by 2 whole square whole divided by 12 students. So finally here I2 value is equal to 1 by 8 times of ml square divided by 12 you will get it. So I2 value is equal to here 1 by 8 I1. 1 by 8 I1 we are identified. So this is the things are relation between I1 and I2. We want to calculate T2 value. So once I am recalling, T is equal to 2 pi root over I divided by mb. Okay students, next what about moment of inertia? Moment of inertia here initially m1 is equal to m. So while dividing into two parts, m2 value is equal to m by 2. So here t is proportional to root I by m only. Therefore t1 divided by t2 is equal to root over I1 divided by I2 into here m2 by m1. Therefore students, here observe carefully, t value is 4, t2 value we want to calculate is equal to root over I1 by I2 value is becomes how much? Nearly 8 only, into here M2 value is M by 2 into this one is M. So this one cancel, this one here 4 times cancel, 4 is equal to root 4 value is 2, here T2, therefore this one is how many times? 2 times cancel, therefore T2 value is equal to, we are getting as 2 seconds. So time period value is 2 seconds we are calculated. Okay students, here which formula we are preferred? For thin magnets I value is equal to ml square by 12, that formula is we are used here. Okay, this is one more simple problem for you. The strength of the magnetic field is increased by 21%. Let I am taking B1 is equal to 100% is present. Now 21% increases, means B2 is equal to 100 plus 21. That's nothing but 121% I am taking. The frequency of magnetic oscillating needle in that field. Let I am taking F1 is equal to 100%, then F2 increases or decreases we want to calculate. So initially delta F value we want to calculate, so I want to find F2 value also. So once recall, we know T is equal to 2 pi root over I divided by MB. Therefore frequency is equal to, we people know one thing, that is F value is equal to reciprocal of time period. Therefore F is equal to 1 by 2 pi root MB divided by I. Is it clear students? Therefore F is proportional, what's the thing here? Root B only. Therefore here F1 divided by F2 is equal to root over B1 divided by B2. So frequency F1 is 100%, 100 I am taken, F2 we don't know, root over this is 100 divided by 121. Okay students, here 100, therefore divided by F2 is equal to root 100 value is 10, root 121 value is 11. So this one nearly 10 times cancel, therefore F2 value is now becomes 11 into 10, that is 110% we got. Therefore here how much percentage increases? Therefore F2 we can represent as 100 plus 10%. Okay, therefore increases by how much? Increases by 10%. This is the result for you. Okay, F value how much increases? 10% nearly increases in this situation. Okay students, the last problem I am solving. A bar magnet is oscillating in magnetic field and its time period is 2 seconds. T is equal to 2 seconds is given. If another identical piece of brass be placed over that of magnet, the period of the combination is how much? Means let this is a T1, this is a T2. So identical thing is placed. For example, this is one magnet, you can think it. On this one we are taking one more identical piece. This is okay, other than magnet is given. In this situation what happened? Initially moment of inertia for one magnet is I am taken. Here for two things is present, means here moment of inertia becomes a double. Okay, so this is the thing. So we know T is equal to 2 pi into root over I divided by MB is the general formula. So from this one here T is proportional to root I, therefore T1 divided by T2 is equal to, we can able to write as I1 divided by I2. Here T1 is given as 2 and T2 we want to calculate, that is equal to root over here I divided by 2I. So this one cancel students, then 2 divided by T2 is equal to 1 by root 2 we will get, therefore T2 is equal to, finally we will represent as 2 root 2 seconds. Answer is becomes 2 root 2. Okay students, these are the things. In next class remaining topics we will discuss. Okay, thank you.